Welcome to yet another video on SRID Cloud. In this video, I want to talk about DHCP in a data center. The L parts or the VMs, the virtual machines deployed in the data center need to get IP addresses from DHCP server. And in this configuration, the DHCP server need not have to be in the local router, but it can be on an external router. So let's get started. So in this topology, there are one switch and a couple of routers, R1 and R2. R1 being the core router and then the R2 being the edge router. And in this particular case, the R2 is also providing the DHCP services. The switch is connected to four compute endpoints, and two of them are in VLAN 100 and the other two are in VLAN 200. And from routing point of view, the VLAN 100 belongs to VRF A and the VLAN 200 belongs to VRF B. And in this configuration, I'm going to create only one DHCP pool per VRF. I'm not able to create more than one because the way I am using the port channels between the routers, which I will explain in a moment. So now let's take a look at the switch configuration. Let me maximize it. Let us look at the running configuration. So the fast Ethernet 00 and 01 are connected to VLAN 100 endpoints, and fast Ethernet 2 and 3 are connected to the VLAN 200 endpoints. And the router is connected to the 15, fast Ethernet 15. Let me do this again. The fast Ethernet 00, 01, 02, 03, these are all access ports. And the 015 is a trunk port. And that is the only configuration in this switch. And all these compute endpoints are configured as DHCP endpoints. No static IP has been assigned to these compute endpoints. And the intention is to create two different DHCP pools, 192.168.3.0 and 192.168.4.0 on the respective VLANs and respective VRFs. And these compute endpoints are supposed to get the corresponding IP addresses from the DHCP pool. So now let's take a look at the R1. Let me maximize it. And let's look at the running configuration. And here are the couple of VRFs defined, VRF A and VRF B. And let's skip all these things. I created an interface port channel 1 and then created a couple of sub interfaces on the port channel, one for VRF A and one for VRF B, one with VLAN 100 and the other one VLAN 200. And I entered the IP address appropriately, like 192.168.3.1 for the first one and 4.1 for the second one. These two act like a default gateway for the corresponding networks. And then I also created port channel 2 and added a couple of sub interfaces on them as well. This is between the core router R1 and the edge router R2. So it's a mirror reflection of what is on the southern side. And then on the physical interfaces, gigabit Ethernet 1 and 2, I set up the, I attached the port channels on them with a channel group 1 and channel group 2. And I also set up a BGP between R1 and R2 with the ASN number 65,000, with the router ID 172.16.1.1, and created a couple of sections for each VRF. The neighborhood is also set up to the edge router, whose ASN is 66,000. And on the other end of the connection between R1 and R2, the IP address is set to 172.16.1.2 for both the port channels, as we will see in a moment. So that's it for this router. And now let us look at the edge router, where we should see the DHCP pool definition. Sorry, show run. So once again, couple of VRF definitions here, similar to R1. And I intentionally excluded the first 100 IPs for each pool. And then I defined those two pools here, VRF A pool and VRF B pool, and specified the default router 192.168.3.1 and 4.1. And I created a port channel number 1, and then 2 sub interfaces on them, similar to what I did on the R1, 1 on each VRF. And then on the physical Gigabit Ethernet 1 port, I attached the port channel. And then finally, I also did the BGP. The router's ID is, ASN is 66,000, and then the ID is 172.16.1.2. And similar to what I did on R1, I created sections for each VRF. And that's it. There is one particular thing that I wanted to mention. If you noticed the DHCP pool definition, I did not include any VRF definition inside these pools. That is intentional. I think based on certain documentations, the VRF definition inside the pool will work only for MPLS VRF. So what we are doing here is VRF Lite. So if you include the VRF definition inside the VRF pools, I mean the DHCP pools, the it will not work. The DHCP address allocation will not work, and I verified it as well. When I removed the VRF definition from these pools, then everything started working. Another reason why I have only one DHCP pool per VRF is because of this port channel definition. It is not possible to create another port channel on entirely different VLAN, for example, port channel 1.300, and on the same VRF, say VRF A, and assign the same IP address. That is not possible. So once again, let me repeat. It is not possible to set the same IP address on both port channels, even though the VLANs are different and both belonging to the same VRF. That is not possible. So that is why for this particular offering and for this particular topology, I'm limited to only one DHCP pool per VRF. So if you have a different opinion or if you have a different method, please let me know in the comments. So this is it. And now I'm going to go to the endpoints and then enable the DHCP client and see if I get the IP addresses. So let's go to the first one, PC5. And I'm going to clear any IP on it. And now I'm going to say IP DHCP. So remember, this is on 192.168.3 network. So we are supposed to get 192.168.3 dot an IP that is beyond 100, because remember we excluded the first 100 IPs from the pool. And there it is, we got the 192.168.3.103 from DHCP server. And so let's go to the other VRF and we maximize it. Clear IP and IP DHCP. And I got 192.168.4.102 in this case. So that is how it is working. I think I forgot to mention one thing. So let's go back to this. Let me clear all these things. One final thought that is very, very important, which I missed. Go to R1, and now I'm going to look at the configuration again. And here it is. The port channel 1.100 and 1.200 facing the switch on this router, they have this IP helper address definition in it. This is the IP address of the router 2 facing R1. So what exactly happens is when this router receives DHCP boot traffic, the router R1 delegates the DHCP address allocation to R2. So basically it sends all the DHCP boot traffic all the way to 172.168.1.2, which is the IP address of R2 facing R1. And the DHCP service in R2 is serving the IP address all the way to R1 and all the way to the compute endpoints. So I hope you enjoyed this particular video, and I intend to produce a lot more videos in similar topics very soon. So thanks for watching, and bye for now.